Myself, Rajendra S. Karale. My qualification is MSc Chemistry year and experience is of 28 years. Now today we are going to discuss about integrated rate equation for a typical first order gas phase chemical reaction. Now here consider the first order. Consider a first order chemical reaction in gaseous phase. That means here A gas gives B gas plus C gas. Now here let Pi be the initial pressure of A gas at time t is equal to 0 and Pa be the partial pressure of A gas after time t is equal to t. Now here the integrated rate law for first order chemical reaction is, here write down K is equal to 2.303 upon T log of R0 upon R. Now suppose this is your equation 1, this is your equation 2. Now put this value in equation 2, we get K is equal to 2.303 upon T log of initial pressure is Pi and here write down Pa. Now here this is your equation number 3. Now calculate the value of Pi and Pa by using the table. Here let pressure of A gas decreases by X atm after time t. That means here, but one mole of A gas on decomposition gives one mole of B gas and one mole of C gas. This is from reaction. Hence, increase in pressure of B gas and C gas are also X atm. Now here draw the table. A gas gives B gas plus C gas. Here initial pressure at time t is equal to 0. Initial pressure of A gas is Pi. This is 0 and this is 0. At time P is equal to T. Here pressure of A gas decreases by X atm. That means here write down pressure Pi minus X. Now here write down atm. Now here observe the reaction. 1 mole of A gas on decomposition gives 1 mole of B gas and 1 mole of C gas. As here pressure of A gas decreases by X atm, that means here this is also increased by X atm and this is also increased by X atm. Now here total pressure PT is given as, that is PT equal to PA plus PB plus PC. That is total pressure is equal to partial pressure of A gas plus partial pressure of B gas plus partial pressure of C gas. Now substitute the value here from the table. That is Pi minus X plus X plus X. Here X gets cancelled. That is PT is equal to Pi plus X, and hence X is equal to PT minus Pi. Now Now here write down where PA, PB and PC are the partial pressure of A gas, B gas and C gas respectively. That means here, what is your aim? Your aim is to find out the value of Pi and PA. Now here PA is equal to Pi minus X. But what is the value of X here? Here X is, here write down Pi minus PT minus Pi. That means here Pi minus PT plus Pi. That is here PA is equal to twice Pi minus PT. Now this is the value of PA. Now substitute this value of PA in equation 3. We get K is equal to 2.303 upon T log of Pi upon twice Pi minus PT. Here this is your equation number 4. Now this equation number 4 is the equation 4 is the form of integrated rate law for the typical first order gas phase chemical reaction. Now here keep in mind, here K is the rate constant for first order gas phase chemical reaction, T is the time, Pi is the initial pressure of the reactant, and PT is the total pressure. How these total pressures are calculated here? Total pressure is equal to partial pressure of gas A plus partial pressure of gas B plus partial pressure of gas C. Now here I don't keep in mind only for NEET and JEE. Now here there are two cases for second order chemical reaction are: number one, the chemical reaction is second order in only one reactant. That is, suppose R changes to product. Here the rate law, that is rate is equal to K into concentration of R raised to the power 2. Now the chemical reaction is second order in two different reactants. That is, here I down R1 plus R2 gives products. Here the rate law, that is rate is equal to K into concentration of R1 into concentration of R2. Now here power of this concentration of R is 2, therefore its order is 2, and here partial order with respect to R1 is 1 because power is 1, and partial order with respect to R2 is also 1 because power is 1, but overall order, that is 1 plus 1 equal to 2. Now here write down the integrated rate law for second order chemical reaction with only one reactant is, that is 1 upon concentration of R is equal to Kt plus 1 upon concentration of R0, that is Kt is equal to 1 upon concentration of R minus 1 upon concentration of R0. That means here K equal to 1 upon T in bracket 1 upon concentration of R minus 1 upon concentration of R0. Now, where K is the rate constant for second order chemical reaction, T is the time required to change the concentration of reactant from R0 to R. R0 is the concentration of reactant at time T equal to 0, and R is the concentration of reactant after time T is equal to T. Now we write down first question. Integrated rate law for zero order chemical reaction is number A, K equal to 2.303 upon T log of R0 upon R. Number B, K equal to 2.303 upon T log of R upon R0. Number C, K equal to R0 minus R upon T. And number C, D, K equal to R minus R0. Now how these terms are read? This term is read like this: concentration of reactant at time t is equal to 0. And how this term is read? This is the concentration of reactant after time t. Now here the question is that the integrated rate law for zero order chemical reaction is, that is K is equal to concentration of reactant at time t is equal to 0 minus concentration of reactant after time t upon t. Correct answer is C. Now next question: integrated rate law for first order chemical reaction is, again number 8, K is equal to 2.303 upon T log of R0 upon R. Number B, K equal to 2.303 upon T log of R upon R0. Number C, K equal to R0 minus R upon T. And number D, K equal to R minus R0 upon T. Here, integrated rate law for first order chemical reaction is like this. That means, keep in mind the integrated rate law for zero order chemical reaction as well as first order chemical reaction. These equations are given in any form. These equations are also given in the graphical representation. Convert that form into such a form and identify the type of reaction, whether that given integrated rate law is for zero order chemical reaction or first order chemical reaction. Remaining part of this unit will be discussed in the next lecture.